Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will know about the communication structure, that is the naming and name resolutions, the routing strategies, packaging strategies, and finally the communication or the circuit technologies. To discuss the communication structure, the first issue that needs to be resolved is the naming and name resolutions. While we are choosing this naming because we want to identify any host within a network and that any process within a host. While we are configuring a distributed operating system or a network operating system, we must first specify that which process is coming from which host, which needs to be migrated, either a data migration or a process migration. Say from within a host in a local process, all process can be identified with an PID or process identifier that is included in the process control block. But as the networks not share any types of memory, so we do not have beforehand any type of information that which process is coming out of which host. So there must be some name resolution which need to be solved, that the process and the host corresponding to that ID. So the naming resolution is used for solving this type of problem. Here a unique pair, that is a host name and an unique identifier, which is a process ID. So the host name suggests that the unique identification within a network, and the process ID or the unique identification number suggests the unification on that particular host. Either the host name can be used on an alphanumeric text rather than a number, because it is very easy to remember, like Bert, Joe, Cole, other than 1, 2, 3, 4, 2, 1, 0, 6, 7. So the host names are always preferable on alphanumeric text rather than number. But there should be an address translator which translates this host name to host number, because the internet or the computer system understand the number more specifically and can act as a more speed on this particular host numbers. So there should be an host names to host address translator which should be given an host number along with the process ID. Now, at earlier systems, they used to keep for each host a table that contains another host name and the address associated with it. The main difficulty with this table is whenever a host name or its address gets changed, so the table in every host need to be get updated on that particular host. So this type of problem is solution by the addressing of this DNS or domain name service. Here a name server is there to present all the hosts that need to keep updated on that name server. So whenever any modification or updation is done, the DNS will be informed on behalf of this host, so that every host need to not get updated about their address changes. So only DNS will take care of these changes, and the host can fetch from the new address of this host from the DNS server only. So the domain name server solves this host name to host address specifically because it supports multi-part addressing, where every part is specified by a period, or let's say bob.edu.cs.home. So here we are saying that the host Bob is from a CS department from home of an edu. That edu is a top level of this name server, which is using for education, say for org for organization, com for commercial purposes, and so on. So here we are done from this reverse way. Like first the edu is get solved, after that from the name server, the host is get solved from downwards. So to solve the name resolution from bob.cs.home.edu, first the name server for edu is asked to give that the home.edu server. If it finds that the solution for the home.edu server, then it returns address of this home.edu server, which in turn asks about the cs.home.edu server. After that, it returns information about this one. Finally, the cs.home.edu server is asked about the address of host Bob, which will be given the actual internet address or IP address, which is generally a low-level address or integer number. For example, say 128.148.10.100. So this keeps the internet address of a multi-part hostname address of bob.cs.home.edu. The main problem with this DNS or the name server protocol is, say suppose that the edu server or the edu name server cannot solve these references, or it cannot find any server names edu. So the entire translations becomes inefficient because the edu server cannot return the address of home.edu, in turn which cannot return cs.home.edu and bob.cs.home.edu. So in this way, it becomes very problematic for the name server to solve the references if the top level server is not available to the user. So there should be a secondary copy of this information that is made to the site, and if the primary get damaged or the edu server fails, then it look for the secondary devices from there which can solve the references. So before the DNS, there was a site that it used to get changed about these addresses, that is an SRI NIC. So whenever this SRI NIC is get updated, so it can be said that the SRI NIC is having the updated address of that particular host, which can be used by any other host to reference solvation of that particular host name to address translation. So it is entirely the responsibility of this DNS server to solve the references and get updated of the edu updation server if there is any changes. The next solution of this is a routing strategy to the communication structure. Routing is become extremely important when a process wants to send messages to another process or communicate over another site B. Say suppose one host at site A want to communicate over a site B. So there should be a router which should be used to get exchange of these messages on that particular client and server, or two hosts on that particular DOS. So from A to B, there can be one static path or multiple paths available to the change of messages. So there are generally three types of paths or routing strategies. One is fixed routing, virtual routing, and dynamic routing. In fixed routing, from host A to B, there is a single path which is established and it cannot be changed until and unless some hardware failure occurs. So the A to B solvation of this exchange messages has to be done only by this single path. So even if these two networking devices are not using this path, the link is to be established beforehand. Now for virtual routing, there is one single link that is established for a session. A session can be as short as a user authentication or as long as a remote login. The last part is a dynamic routing. In dynamic routing, when the message is sent, then it is upon the host which will decide that which routing is to be selected, if there is available a multiple paths. Say for sending message A to host B, it first sends from A to B, then B decides to send it to C, then finally C decides to send it to D, and D will send the message to finally B. So in this way, there should be multiple paths that will require from sending message A to B through dynamic routing. So there are reasonable trade-offs between these routing strategies. First, if we consider that for the fixed routings and for the virtual routings, the link failures and the load balancing is at least. Because from host A to host B, there is a single path even for a session in virtual routing. So whenever these hosts are not using actively, then also the bandwidth is used so that the link usage is minimum and the link failure it cannot suffer because it has to follow even if the network is very slow between these paths. So it is then recovered a general for virtual routing and a greatly in dynamic routing. But also, if we consider the fixed and virtual routing, it assures that the message will be delivered in order in the exact sequence it has been sent. But for dynamic routing, it is not given that not assurance that the message will be delivered in the exact order it was sent. So there should be a sequence number that is attached with every message so that when the messages will be get into the server side, it will be made in proper order. Dynamic routing is then best applicable and then adopted by many of the network user systems because of its flexibility, but also it is more complex because it has to choose between multiple paths very wisely that which path is to choose. Say for those networks or the two hosts that is using, if there are multiple paths available, so the least communication protocol which will take place and as well as the maximum bandwidth that can be used and the routing protocol will be used. So there are gateways to connect between different types of networks and there were small routers to connect between similar types of networks. So say if there are LANs that can be connected with small routers and when the LANs are to connect with another type of LANs that are connected through the gateway routers. So there should be a routing protocol which will decide that choose which routers among the LANs and WANs. Next is the packet strategies. When we are talking about the packet strategies, it is generally implemented with a messaging sent by one host to another. Now the messages can be as long as in total of 100 megabytes or to 10 gigabytes. So the message needs to be divided into fixed size packet, frame or datagram. Now the packets needs to be sent from one host to the other host. But the main problem with packet switching is that the packets can be sent from one host, but it is not guaranteed that it will reach the other host or in order. So there should be a feedback mechanism or a feedback packet that is sent by this destination that it has already got that particular packet. That the feedback packet sent by this destination host will be reached by this server host. So in this way the packets are not used because they can be in an unreliable and insecure way to send their messages one another. The next is the connection strategy. As we are talking about that communication from one message to another and from one host to other machines, so there must be some connecting of ways to another. So there are three connection ways between these host or machines. One is circuit switching, another is message switching, and the third one is packet switching. In circuit switching, before the communication can take place between two hosts, there should be one established dedicated connection that is made between them. So after the connection is established, then only the host can communicate with each other and can send messages over this link. Now these two links can be used by only two processes and it should be secured that one link should be linked with two processes and the two processes has linked with only one link. So that these two processes are not actively using the link but the link will be still there, still the processes needs communication between them. The next type of switching is message switching, which generally covers the disadvantage of circuit switching. It uses the same established link but only for a shorter period of time, that is for sending a part of the message. Whenever the next part of the message will be sent, then another link will be established on that basis. So in this way, the message switching provides a better communication mechanism than circuit switching, that is gets established a link between two hosts whenever the message is practically sent between them. If they are not using that link, then it can be reused by another host for sending messages. The last one is packet switching. In packet switching, first the messages are brought into divided fixed size packets and then these packets are sent along these links. In a more secure way, when the host can send messages in terms of packets to the sender or the destination, then the packets can be again reassembled at the destination sites and terms of the messages. And then the message should be read by the destination. So if there is one packet that is sent between this host and this destination, then the more secure way is to use one connection. But if there are more packets, like a message is divided between number of packets, then there should be a sequence of order that should be maintained to get the reassembled in a proper sequence. So the obvious trade-offs between these three techniques is circuit switching requires a substantial amount of time to set up and it uses the less amount of bandwidth as it can. But it also doesn't suffer from the overhead for keeping the shipping out the destination because it has some dedicated established link, so it is sure that the message will be sent by the host definitively received by this address of the destination. As with this packet switching and message switching, the more overhead of keeping the shipping information in a sequence order need to be done. But the packet switching is reliable and secure if the database link is secure in a way, and it is adopted by most of the DOS or network operating system, as it provides a mechanism of dividing a longer message into packets. So that is all for the odd communication structure strategies. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.